All right, let's graph this logarithmic function. The first thing we want to do is draw the parent function or the basic function. Let's call it y hat. So the basic function or the parent function here is actually called log base 2 of x. Let's make a quick t-table for this. X and y hat. So notice the domain for y hat is x greater than 0. So why don't we start with the 1/2 value? Well, what's log base 2 of 1/2? That's equal to log base 2 of 2 to the negative 1, which equals negative 1. So we have negative 1 here. Let's pick 1. When x is 1, we get log base 2 of 1, which is just 0. Let's pick 2. 2, we get 1. And let's pick 4. 4, we actually get 2. Now, the transformation here says, take your parent function or basic function and move all the x values 3 units to the right, and then move the y values 2 units up. Plus 2 means add the 2 units to the y value going up. This x minus 3 says move your x values 3 units to the right. Why don't we check this? And we could simply check this by making another t-chart. This time we're going to make it for x and y. So if we add 3 units to the 1/2, we actually get 7 halves. So try evaluating y is equal to log base 2, 7 halves minus 3. Well, that's just another way of saying 1/2. And then we add 2 units to the y value. So y is now equal to log base 2 of 1/2, add 2 units to the y value. So y is equal to negative 1 plus 2. That's just equal to 1. Let's put the 1 right there. Let's add 3 units to this 1. Add 3 units to that 1, we get a 4. Now we add 2 units to the 0. If we add 2 units to the 0, we get 2. Why don't we check that? Log base 2 of 4 minus 3. Well, that's just log base 2 of 1, which is 0. 0 plus 2 is 2. Look, it matches, and we get a 2. Why don't we check one more? Add 3 units to 2. Add 3 units to this 2. What do we get? We get 5. And then add 2 units to this 1. We get 3. Once again, let's check it. Log base 2 of 5 minus 3. Well, that's just log base 2 of 2, which is 1. 1 plus 2, you get 3. Whoa, that is so cool. I think we're ready to graph. So if you want to, you can graph the parent function to actually see the transformation. But if you're comfortable with just graphing the log function that you're supposed to, you could do that too. I was always taught to draw the parent function anyway. So 1/2 negative 1. 1/2 negative 1. And then 1, 0. And then 2, 1. Then we have a vertical asymptote here. That vertical asymptote is called x equals 0. Let's play connect the dots. And that is the parent function. Now, I did make a mistake here. I need this to be dotted. So let's try that again. Why do I need this to be dotted? This isn't the function we want. This is more of the function that we transformed. What is the function we want? Well, we look at 7 halves, comma 1. 7 halves, comma 1 is 3 1/2, and comma 1, dot. Oh, I should move the vertical asymptote. How do we move this vertical asymptote? Make sure you go 3 units to the right. This vertical asymptote is called x equals 3. And we have 4, 2. Right about there. What else we have? We have 5, 3. 5, 3 is about here. And let's make our logarithmic graph. This is the one we want. And there it goes. Now, why don't we check its domain? Notice from the domain here, you can actually find that. The domain says here we need x minus 3 is greater than 0. Well, that's really saying x has to be greater than 3. So the domain in interval notation is simply parenthesis 3 to infinity. You can also spot the range here. The range is actually looking at all of the possible y values. So it does look like it extends to negative infinity. And then you could read that it actually extends to positive infinity as well. So we could find the range. The range of your function is simply negative infinity to infinity. What else can we describe? We could describe a vertical asymptote. The vertical asymptote is x equals 3. We have that as well. Why don't we try to find the x-intercept? There is no y-intercept, so maybe a point of interest is actually the x-intercept. So how do we find this dot here where it crosses the x-axis? Well, that's when y is 0. So 0 is log base 2 of x minus 3 plus 2. We want to isolate our logarithm, so we have negative 2 is equal to log base 2 of x minus 3. By definition of log, we have 2 to the negative 2 is equal to x minus 3. Well, then x is now 1/4 plus 3. Well, what's 1/4 plus 3? Well, that's another way of writing 3 1/4. X is equal to 13/4. Let's translate our x-intercept into an ordered pair. So our x-intercept translated as an ordered pair is 13/4, comma 0. And so there's the graph with lots of different characteristics. I hope that helps.